Hello students, let us continue with some other problems of the miscellaneous part of the chapter 2. And now see this question. Let a is equal to 1, 2, 3, 4 and b is equal to 1, 5, 9, 11, 15, 16 and f is equal to 1, 5, 2, 9, 3, 1, 4, 5 and 2, 11. Are the following statement is true? Whether f is a relation from A to B. You have to check whether f is a relation from A to B. To check whether it is a relation, we have to check whether f is a subset of A cross B. Here, see the element of f. Whether these elements are in A cross B, you have to check, that's all. 1, 5. Whether 1, 5 is in A cross B? Yes. Here in A cross B, there will be 24 elements will be there, right? There will be 24 elements. 1, 5 is also there because here 1, 1, 1, 5 is there. 2, 9, 2, 9 is also there. Here there is a 2 and 9, 2, 9 is there. 3, 1 is there. 3, 1 is there. 4, 5 4 5 is there, 4 5 is there, and 2 11 2 11 is also there. Therefore all these elements are there in A cross B. Here all the elements are in A cross B, that's why f is a subset of A cross B, therefore it is a relation, and the first statement is true, it is a relation. Whether f is a function from A to B, and how to check whether this is a function? Every element of A occur as a first element. Yes, 1 is there, 2 is there, 3 is there, 4 is there. The first part is okay. Whether any element of A occur as a first element twice? Yes, here 2, 9 and 2, 11 and 2 occurs as a first element, therefore it is not a function. The reason is 2, 9 and 2, 11. Both the elements of f have the same element, that is 2 as a first element. That's why it is not a function. Now we take this question. Let f be the subset of z cross z defined by f is equal to ab, a plus b, where ab belongs to z. Is f a function from z to z? Justify your answer. And here if any two distinct elements have the same image, then it is not a function. And I will give this example, just check here. And 6, 5 belongs to f. The reason is 6 can be written as 2 into 3, 2 into 3 and 2 plus 3. That's why here you can write 2 into 3 and 2 plus 5, which is belongs to f. And 6 can be written as 1 into 6 also. And if you write 1 into 6, what happens? 6, 7 belongs to f, because you can write it as 1 into 6, 1 plus 6. And that's why 6, 7 is also in f. And these two elements are in f, but and both the elements have the same first element, that is 6. Therefore, this is not a function. Therefore, f is not a function. Now, see this example. Let a is equal to 9, 10, 11, 12, 13 and f from a to n is defined by f of n is equal to the highest prime factor of n. Find the range of f. And range of f means you have to find the image of the elements of a. And you have to find the highest prime factor of all these numbers. You know how to find the prime factors. Among the prime factors, you have to take the highest prime factor. Now let us take the first element 9. What are the factors of 9? 1, 3 and 9. Which is the highest prime factor here? 3. And this is the image of 9. And what are the factors of 10? 1, 2, 5, 10. These two are prime factors, and which is the highest prime factor? 5. And therefore what is the image of 10? 5. And if you take the 11, what are the factors of 11? 1 and 11, because 11 is a prime number and 1 and itself are the factors. Which is the highest prime factor? 11, and therefore the image of 11 is 11. And what are the factors of 12? Factors of 12 are 1, 2, 3, 4, 6 and 12. And here, what are the prime factors? 2 and 3. And which is the highest prime factor? 3. And therefore, what is the image of 12? 3. And what is the image of 13? 13, because the factors of 13 are 1 and 13, and the prime factor is 13, and that's why we will have the image set 3, 5, 11 and 13. Here 3 is repeated, you have to write only once. You know that while writing the set, if the elements repeats, you have to write it only once, and therefore the range of f is 3, 5, 11, 13. Now see this question. Find the range of each of the following function. F of x equal to 2 minus 3x, where x belongs to R and x is greater than 0. It is given that x is greater than 0. When x is positive, 3x is always negative. And 2 minus some positive quantity is always less than 2. And that's why you have to analyze like this, and you can write the range of the function 2 minus 3x, that is minus infinity to 2. Here 2 is not included because x is always positive and this cannot become 0. And when it is not equal to 0, f of x never becomes 2. And that's why it's open interval minus infinity to 2. And second function f of x equal to x square plus 2. X is a real number and x square plus 2 cannot be less than 2, because x square is always positive. X square plus 2 is greater than or equal to 2, and therefore the range of the function is 2 to infinity. And f of x equal to x, where x is a real number. X is a real number, therefore x takes all the real values, and therefore what is the range of the function? The set of real numbers. And this completes this chapter, relations and functions. Thank you.